Okay, in this problem we're going to do a box problem. We have a paper company and they are going to manufacture a box that has no top by removing squares of width x from the corners of a 30-inch by 70-inch piece of cardboard. So our given, we'll draw right on this diagram. We have 30 inches by 70 inches. And when we fold this box up, we're going to cut these little X corners out, which are labeled X on one of them. So all of those little squares are coming out. And the question is, write an equation that models the volume of the box in terms of the size X, square removed. Determine X so that the box has a volume of 580 cubic inches. So that was a correction that I noted the other day. And determine the maximum volume of the box that could be made. So we want to find two different things. One, what size squares would you have to pull out to make a volume of 580? And then the second one is a different question. What's the biggest box we can make, biggest volume? So we're going to need to identify the inside of this box because we're going to fold up this edge. That's going to be the side of the box, and this is going to be a side of the box. Those are going to get folded up. So if we look at the dimensions, we have 70 minus 2x because we're going to cut off those two x pieces. And then the width of it is 30 minus 2x. And the height, when you fold it up, the height is going to be x. So we have our given. The unknown is x, so that the volume is equal to 580. And the maximum volume we can make. So there's two different questions. And we're going to let x represent the size of that box. Now the equation for a box that is a rectangular prism like this is length times width times height. And we're going to substitute in the length is 70 minus 2x. The height is 30 minus 2x. The width, and the height is x. And that's our volume equation. So you can plug that into your y on your calculator, and that will give you the curve that models the volume of this box based on x. And we'll go ahead and do that, but let's think about what should x be. So if we were to look on this window and we want to put our x min and our x max, well, x is the size of this little square. So the minimum it can be is 0. And I tend to like to put the minimum more in a little bit to the left of 0 so I can see the axis. And the maximum this could be x is 15 because half of 30 is 15. So that would basically chop the box into nothing. But the maximum that x can be is 15 based on our diagram here. Now in terms of y min and y max, well, let's think about it. The volume minimum is going to be 0, so I'm going to take my minimum volume to be minus 5. And I know for the first question, I have to have a volume bigger than 580. So I'm going to go ahead and put y max to be 1,000 for the first part, and then we'll graph it. So here's the graph with the window settings that I specified, where we have minus 5 on the x to 15 and minus 5 on the y to 1,000. And you can see it's this graph here. That's the graph of the y equals 70 minus 2x times 30 minus 2x times x. Okay, and I also added the second equation. I added y equals 580, and that line is right here. So this intersection point right there, that's going to give us a box that has a volume of 580. And this window is not so great, so I want to blow this area up, so I'm going to make my x max 5 instead of 15. So I'm going to take a new picture. And you can see on this new picture that I changed the x-axis. So now when we look at this picture, I have 5 to negative 5, but I left my y-axis the same, negative 5 to 1,000. And this line here is y equals 580. And this line going up that curve there that you can see, that's the equation. And that point right there, that's the intersection point. So I did a calc intersect, and you can see the answer down the bottom here. We get an intersection point when x is equal to 0.28. So a little bit more than a 1/4 inch deep. And so the answer to the first part of the question was that the little box that has to be cut out, remember x is the side of the little box, that has to be just a little more than a 1/4 inch, 0.28 on each of the side, 0.28 inches. So that's the answer to the first part. Now the second part of the question says find the maximum. So we already have the equation in our calculator, and now we need to zoom out and see what the maximum is. So clearly, looking at the graph that was on this picture, it looks like it's going to go up quite a bit. So I'm going to go back and change my x max. Again, I'm going to go back to change it to 15 because we could see the other side of the graph then. And I'm going to change my y max. We're at 1,000 now. I'm going to make it 10,000 because it looks like it's going up pretty steep. Let's take a look at that. And this is the window we get when we set x min is equal to -5, x max is equal to 15, y min is equal to -5, and y max is equal to 1,000, is equal to 10,000, so that we can see the top. Now you could have used maybe 6,000 and still would have fit, but I can see this curve pretty clearly here, and I went on and I did a calc max. You can see the answers here. And I got a maximum. If I cut a square, a little box out of the corner of 6.528 or 6.53 inches, I'm going to get the biggest volume I can get. And the biggest volume box I can get out of that piece is 6298.6 cubic inches. And so that's the answer to the second question that was asked. Okay, so again, that's number 10.